All right, so you're writing your lab report and you've gotten to the point where you have a percent error, you've done the over-under method, and you want to know what does that mean with your data. So what we're going to look at here is the percent error isn't good or bad without that over-under method reference. Okay, so that's why we needed to do the short and the long to see is that percent error acceptable or not. Do these two data sets match? Does the data that you calculated, which would be your short, average, and long, match with the data that the ball actually landed at? Okay. Now, the next step is once we identify, hey, does this match up, we want to know what could have caused your error, and we really want to think about could, because we don't really have a good way of narrowing it down and proving that. And we want to really focus on your data, not just any old data, your specific data. So let's take a look at 3 examples over here. So the first example here, I have my 5 data points that I marked with X's, and then I marked the average with this dot with this line through it. And so you'll notice this first data set, one of them landed in my range of acceptable areas, but the other 4 did not. And what this is really saying, this short and this long, is that's saying this is the acceptable range for variation from me rolling the ball. Okay. So the longest it could be was here. And so what I'm seeing is I'm seeing a general trend of longer. So why might that ball have landed further than I expected? What could have resulted in my data going long? And so you'd have to come up with some ideas about what it could have caused that. Some easy ones to fix would be double check that height of the table. Okay? Maybe you thought the table was shorter than it was. Double check the height of that table. Okay? Because if you find out, hey, my table is actually a little bit higher, you can just shift those lines and see, does your data match up now? Okay? If it's something like, I might not have had my IR sensors exactly 1 meter apart. Okay, so now you've identified what could have done it. Now, how could it have caused your data? So were those sensors too close together? Were they too far apart? Which one of those two would cause your data to end up like this? Okay, and that's another one you could think of maybe for this data set 4 down here too. All right, let's move on to data set 2. This is ideal. So we had some land long, some land short. Perfect. That's what we would expect. This means that whatever percent error, however far off that average is from that average, is the result of variation. We expect all our data points to land in this range. They do all land in that range, some above, some below. That percent error is totally fine. We're all within 1 sigma. We're good. Now, data set 3 meets that criteria. They're all within this range. Okay. But what we see is they're all kind of short, but in that range. So there must be a small impact outside of variation that's causing that. And so what we'll want to do is we'll want to think, okay, what small thing could make this land short? And so maybe you think about, okay, how about that edge of the table? It's a little curved. Okay, so maybe it started falling a little sooner than what I expected. Or it dropped off from a different height. Okay, so that might have a small effect. Or maybe there was a little resistance and it slowed it down and made it land short. If you're going to claim air resistance, make sure you come up with 2 solutions, simply because air resistance is going to be pretty low on this steel ball. Okay? And then our last one down here, number 4, all landing significantly short. What could have caused that? So something that could have caused, say, 4 and 1 also is your table might not be perfectly level. So something you'll want to do is just go grab a ball. If you get like a data set 1 or 4, even if you get 3, just grab a steel marble and set it on that table and see, does it roll backwards? Meaning that it was kind of sloped up. So it slowed down as it got to the end, and so it would land short. Or maybe it was sloped at an angle and sped up as it was going. All right, so think about that as well. And so our goal here is, once we identify where we are in that over-under, are we within 1 sigma? And in some cases we'll be within 1 sigma, but there's still another possible source of error. Sometimes we'll be in that 1 to 3 sigma range. And so we're trying to identify what other small sources of error could there be. And again, we want them to identify them and be specific about how they caused your data. Walk me through those steps. All right, hopefully that helps you write that conclusion in that results section on that lab.